Hello everyone, welcome back to Sai Homeschool. Please like, share and subscribe my channel. Today we will discuss the another chapter of class 10 chemistry, that is acids, bases and salts. What are acids? What are bases? So we already know that acids are sour in taste, bases are bitter in taste. Sometimes you will observe at home if we eat food, someone in your family suffering from a problem of acidity. So that overeating. So what did you suggest? Means here it is acidity. So that we have to suggest base to avoid that acidity. So acids are sour in taste that change the color of blue litmus to red litmus. Bases are bitter in taste. They change the color of red litmus to blue litmus. That is, we'll see. So one more chemical definition of acids, we can say that the substance that gives OH plus ions, those are called during the chemical reaction, the substances that gives H plus ions is called acids. Acids have two types. One it is strong acid, one it is weak acid. Strong acids means the acids which completely dissociates in water. Dissociates means break down. It will completely break down in water. Weak acids are nothing but the acids that does not dissociate, that does not completely dissociates in water. For strong acids, we can take example HCl, that is hydrochloric acid, sulfuric acid, nitric acid, phosphoric acid and chloric acid. For weak acids, we can take examples acetic acid, hydrogen cyanide, then benzoic acid. Then bases. So as we know that bases bitter in taste and it turn the color of red litmus to blue litmus, that is bases. So chemical definition, what you will tell chemical definition for the bases? That is the substances that gives OH minus ions in the chemical reactions. That is acids will give H plus ions, then bases will give OH minus ions. Here also there are two types of bases. One it is strong bases and one it is weak bases. Strong bases are nothing but the bases which completely dissociates in water. Example, sodium hydroxide, potassium hydroxide, calcium hydroxide. Weak bases are the bases which does not dissociates completely in water. We can take ammonium hydroxide is a better example for weak bases. So now we'll see indicators, types of indicators. So what is meant by indicator? So indicators are nothing but the substance which is used to test whether the given solution is acid or base. That is called, what is called? That is called indicators. Indicators, we have three types. One it is natural indicator. In natural indicators, how we will get this natural indicators means the substances that are obtained naturally, means here we can see that the naturally occurring that substance that will be get it from the plant, that is lichen plant belonging to the division Thylophyta. So natural indicators are nothing but those indicators obtained from naturally. That is, one it is litmus solution we can take. That litmus solution is obtained from the lichen plant. This is important. So litmus solution is obtained from this lichen plant. So after using some chemical methods, we will convert that litmus solution into the litmus paper. And another natural indicators are, here we can observe turmeric and red cabbage leaves are the another examples of natural indicators. Okay, then second one is synthetic indicators. There are three types of indicators I said now. One, it is natural indicators, synthetic indicators and olfactory indicators. This is natural indicators are obtained from the litmus solution. This litmus solution extracted from lichen plant. Okay. Then synthetic indicators. Synthetic indicators which are prepared in a laboratory or which are prepared by the man. That is, one it is phenolphthalein indicator, another it is methyl orange. Those are the two indicators, that is synthetic indicator. Then third one is olfactory indicators. So olfactory indicators also, it is naturally available indicators. We can observe the change in the taste and smell when we use this olfactory indicators. We can observe the acid or base. Given base is whether it is a by changing a taste and smell. So the indicators whether the substance is acidic or basic. So by change its color, those some substances whose odor changes in the acidic or basic media, those are called olfactory indicators. This is the third type of indicator. For example, onion, vanilla or cloves are the examples for olfactory indicators. So now we can understand that there are three types of indicators. One, it is natural indicator. Second, it is synthetic indicator. Third one, it is olfactory indicators. Natural indicators are, here it is, naturally obtaining indicators from lichen plant, that is litmus paper. Then synthetic indicators are which is prepared by man, that is phenolphthalein indicator and methyl orange. Then third one is olfactory indicators. This is also naturally available, that substances which whose odor changes in acidic and means by changing the smell and taste of the solutions we can identify whether it is a acid or base, that is called. So now we can understand that the indicators are nothing but the substances which is used to identify whether the given solution is acid or base, that is indicators. So when we come to the sample solutions, how it will be happened, I'll show the litmus paper how it will be turns in shots. I will show you slides. So when we add acid here, when we take acid here, what will happen when we take acid here? What will happen if you take red litmus? Red litmus will be same. It will be red in color. It will not change its color. So when we take blue litmus into the acidic solution, blue litmus turns to red. Okay. Blue litmus turns to red. Then if we add acetic acid into the phenolphthalein indicator, usually phenolphthalein indicator is a colorless solution. So that if you add acid into that, so it will be remains same, means it colorless solution will be obtained. It will not change its color. So if we add acid into the methyl orange solution, this also it will be turned to red. Then you take a sample solution that is a base here. So if we take base Here, what will happen if you take a red litmus? Red litmus turns to blue. Red litmus turns to blue. Then blue litmus, if we take blue litmus remains same. It will be same. If we add phenolphthalein indicator to the base, it will become pink color. It will change as pink color. If we add methyl orange to the basic solution, the color of the solution will be yellow. That is, so if we take any one example in the place of acid, acetic acid, red litmus remains red, blue litmus turns to red. So phenolphthalein indicator solution will be colorless, means as it is, there is no change in the, if you add acid into that, then methyl orange will be changes into a red. If we take base example, sodium hydroxide, if we put red litmus into that, it will be remains blue color. Then blue litmus turns to, sorry, red litmus turns to blue. Blue litmus remains same in the basic solution. Then phenolphthalein indicator, if you add as usual, base if we take, it will be changed into the pink color. Methyl orange if you take, it will be turn into yellow color. So thank you for watching. From next classes, we'll see how do acids reacts with bases and how do acids react with metals. Acids and bases react with metal carbonates and metal hydrogen carbonates. So please subscribe.